For your information, we are really grateful because we managed to complete our MAT 183 assignment within the time given by our lecturer, Madam Nur Azila binti Yahya. This assignment cannot be completed without the effort and cooperation from our group members, Anna, Atia, Farisha, and Aisha. We also would like to thank our lecturer for the guidance and encouragement in finishing this assignment and also for teaching us in this course.
Assalamualaikum. My name is Annalena binti Mazuki. My student ID is 2020494628 and I'm from AS 120212.
Assalamualaikum, my name is Siti Aisyah binti Abdullah. My student ID is 2020816034 and I am from AS 120212.
Assalamualaikum, my name is Farisha Nur Nadira binti Fuad. My student ID is 2020498434 and I am from group AS 120212.
Assalamualaikum, my name is Atia binti Ahmad Sukri and my student ID is 2020604242 and I am from group AS 120212.
What is differentiation? So, differentiation is a process to find the function that produces the rate of change of a variable with respect to another variable. Differentiation also produces a function that represents as a slope. Through differentiation, slope can be known on the graph of a nonlinear graph at any point. There are 5 applications of differentiation. For the first one is related rates. Second is analysis of function 1. Third is analysis of function 2. Fourth is applied maximum and minimum problem. And the last one is Rolle's theorem and mean value theorems. In this video, we're going to discuss one of the applications of differentiation, which is related rates. So, what is related rates? Related rates is a problem involving 2 variables that change at the same time. When we know how these variables are related and the speed of one of the variable increasing or decreasing, then we can calculate the speed of other one that we don't have the information of their speed. In the calculation, it will involve an equation that relates to 2 variables and taking the derivatives equation with respect to time.
Problem statement. Water is being poured into a cone-shaped cup at a rate of 50 cm cubic per second. If the cup has a height of 8 cm and a maximal radius of 3 cm, how fast is water rising when it is 4 cm full? This question is quite confused. Maybe we can ask someone who is expert to solve these problems.
Step 1. Draw a conical shape and label R equals to 3 cm and height equals to 8 cm. Next, list the keywords from the equation which dV over dt equals to positive 50 cm cubed when h equals to 4 cm and we are going to find the h over dV first. Why the dV over dt is positive? It's because of the water is being increased. If the water decreases, it will become negative. After that, write an equation that relates the amount of interest, which is dH over dt equals to dH over dV times dV over dt. Step 2. Find dV over dH by using V equals to 1 over 3 pi r square h. But there are 2 variables in this formula, which is r and h. How to solve it? So, we need to express r in terms of h by using ratio r over h equals to 3 over 8. And we get r equals to 3 over 8h. Next, substitute R equals to 3 over 8H into volume formula, then solve it. And we get V equals to 3 over 64 pi H cubed. After that, determine the dV over dH by differentiate the V, and we get dV over dH equals to 9 over 64 pi H squared. Step 3. Substitute dV over dH equals to 9 over 64 pi H squared and dV over dt equals to 50 cm cubed into dH over dt formula, which dH over dt equals to 1 divided by 9 over 64 pi H squared times 50. So we get dH over dt equals to 50 divided by 9 over 64 pi H squared. Step 4. Substitute H equals to 4 cm into dH over dt equals to 50 divided by 9 over 64 pi H squared. When H equals to 4 cm, dH over dt equals to 50 divided by 9 over 64 pi times 4 squared. So the final answer is dH over dt equals to 200 over 9 pi cm per second.
The problem is calculated using the application of differentiation method to compute the rate of change. We can precisely count the differences in changes that occur. Here we have stated some website links as our references while carrying out this task.